Hello, friends. Welcome to our very new series of webinars. The title is Innovations in Environmental Education. So today, we invite Robert Grover, the founder and CEO of databot, to share why databot should be in every classroom, from preschool through college. And I'm Irina Tuli, one of the founders of EdTech. Let me just first, so while you are still first joining the webinar, use this time to tell you what EdTech is doing and why I love to be here. So EdTech is your one-stop destination to a wide range of innovative EdTech tools, from well-known manufacturers to emerging innovative companies. We search all over the world for technology, mainly with physical component, that can bring value to teaching and learning. So we do in-house testing to save your time and share our findings through workshops, PDs, trainings, and webinars like this. We are certified minority business enterprise and on national and state contracts. We have many programs and we continue to design them, like grant supporting services, bundle customization, or our own monthly $500 grant for 2 educational programs. So I truly love what we do, and I trust that we can help you. So visit our store or talk to us about what you need. But our mission doesn't stop with our deep commitment to vetting EdTech products. In partnership with educational organizations like ESA, so teaching centers, we also invest in pedagogical research to explore innovative approaches to teaching and learning. And now, drum, I'm proud to introduce our latest proposal, eco-education, the framework for education using ecological concept of interdependence, diversity, and beauty, where nature is both a classroom and a co-teacher. We believe that this framework helps educators to intentionally create the environment for active learning where our students love to learn and can develop their eco mindset that drives them towards sustainable actions. Paul Rubio, the co-author of this work, is in the chat room with us, and he is open to answering any questions they might arise. Paul has 4 decades of experience as a public school educator, school administrator, and tech integration specialist. He is also an adjunct faculty at SUNY Pulse School of Education and assistant director of Mid-Hudson Teacher Center. We believe that we can do the same for our children as for our planet, to design a system in which both are thriving. We, as educators, can and should be a part of the solution. And our model of ecological education aims to create a sustainable learning environment. Our model is a map, a compass to show the direction, but the journey is truly and completely yours. And let's add one more component to the system, innovative tech tools. And Robert, next, perfect. What tools are we talking about? They are commonly known as STEM, physical computing, or maker-ed technology. In my mind, they are a concentration of creativity in material form. They represent the knowledge and skills of their innovators and inventors. So the meaningful use of this technology in learning can reveal its creative potential and resonate with the hidden, internal, and often suppressed creativity of teachers and students. The founder of one of these tools, databot, will start his sharing right now. So welcome, Robert.
Thank you very much. Thanks for the introduction, and very excited to be here today. Thank you. So my background, I've been in STEAM education before it was called STEM, and started in 1988, back when OTC Lego and those kinds of products were out. And those early STEM products had the same kind of hallmarks, because you had kids that were able to do hands-on interactive experiences. There was lots of creativity. And, fast forward 30 years later, I've seen lots and lots and lots of different types of products, curriculum, training programs. So in 2019, I co-founded databot, and it's based on all of that experience, of course. And databot's a really fascinating product because it combines so many capabilities in one simple device. Now, in terms of what it is, it's a multi-sensor device. It's tiny enough to fit in the palm of your hand. You can see it in the palm of the hand of the girl in the picture to the right. And she's doing an activity in physics called ninja physics, okay? She's trying to hold databot as steady as possible and balance 9.8 meters per second squared on the z-axis. And a lot of things are going on when students are interacting with data in this live fashion. And a lot of it is immediate feedback. And the research shows us that immediate feedback in terms of abstract science concepts makes an enormous impact in terms of comprehension. So that's really the short version of databot. Kids are going to be interacting with the sensors on board. They have live experiences that provide direct feedback to the scientific world, and it's fun, engaging, and highly effective. So I'm going to give you some examples throughout this presentation. And at the end of it, there's an appendix. We're going to share this presentation with you at the end. But in that appendix, I think there's 18 different examples that show educators using it everywhere from kindergarten clear through high school. So this slide, very briefly, focuses on the research, which I was just mentioning. Now, the quote at the top, I extracted from one of these papers because I think it really, it's really driving home the point in terms of immediate feedback and the results that you get from that. So only the simultaneous display of real-time data resulted in significant learning, thereby emphasizing the importance of immediate feedback through real-time data display. So that's 99% of the kinds of activities that we're doing with kids when we're doing science explorations. They're having immediate feedback, whether they're interacting with carbon dioxide levels in the atmosphere, atmospheric pressure levels, acceleration. And we'll see some examples of that as we go. But the research, and this research paper we'll share with you as well, it's a compilation of over 3 decades of research that shows just how effective sensors really are. This slide is a great example of that immediate feedback. Okay, so this is a simple activity that I do with kids and educators when I first introduce them to databot. You turn on databot, it's very easy to use. You connect to it by a Bluetooth connection with that app that you see in front of you. And it'll connect by Bluetooth, and then you can select what experiment you want. So out of the long list of sensors, in this one, I select CO2. You tap on it, and it begins immediately displaying CO2 levels in the room. And then if you have a student just breathe on it, and they're watching the graph, you get this immediate spike. And what this does is, of course, takes this abstract concept of respiration. I take in oxygen, I exhale CO2. That's a very well-known fact that we present in textbooks and lessons all the time, but now suddenly it's very real. And then kids can actually start playing with that. And that's the whole nature of databot, is to turn data into the manipulative itself. So kids learn that they can hold their breath and they'll get a higher level. So you're starting to get the idea of how you interact physically with data. So it's really redefining how we use sensors with kids. Now there's lots and lots of sensors out there. They range from very inexpensive to very expensive. But most of those are designed, for example, in the science world, to do traditional lab experiments. We design experiences where kids are physically interacting with the data, and we'll show you some examples of those. So I'm going to give you a very quick tour of databot, and then we're going to take a look at how people actually are using it. So this is a close-up. Now, databot is quite small. I've got one here I can hold up to the camera. So fits in the palm of your hand. They're 34 grams, so they're quite light. We have people launching them on air rockets, putting them on drones, all kinds of things. And that's one of the advantages of having all of the sensors in one device, and also having it be very small, because you can actually incorporate it into other experiments. On the right-hand side, you're going to see a long list of sensors, right? And these are all built into the databot with the exception of the temperature probe down here towards the bottom. On the left-hand side of our databot, you'll see two ports, and that's where the temperature probes plug in. You can do two simultaneous temperature readings. The rest of the sensors are all built in. So for example, you see these different modules that are labeled. And this is one of the great things about databot. It's clear, so kids can actually see the technology. The activities that we do actually introduce kids to how the sensor works, how it's used in the real world, and then provides them with some really fun activities where they start to understand, the scientific data that it's displaying. But I'll give you just a couple of examples. We won't go through them all because there's so many. But for example, light, that particular module has both ambient light and color, so it outputs some RGB levels in lux. It also has a gesture sensor built in for coding. And that means you can sweep left or right, and it'll recognize your motions and you can have it respond. So that's another piece of databot that differentiates it from all the other sensors out there, is it's a physical computing device. So out of the box, super easy to use with Visi, but there's also a computing side that you can venture into if you like. I'll show you just a couple of other modules here. This one labeled TOF is time of flight. So that is a proximity sensor. It bounces a little laser beam off of an object and then times the round trip and determines the distance. That's good for up to 2.5 meters. Down here, we've got air pressure, which we also use to determine altitude. You've got a sound intensity sensor, UV index, humidity. The air quality sensor here on the left gives you CO2 readings and volatile organic compounds. Now, if you start thinking about this in terms of environmental studies, so many things that you can do. In fact, if you look at that list of sensors on the right-hand side, I call it a survey because you literally can do a little bit of everything. You can do physics, chemistry, life science, you can do earth science, and you can also do environmental activities. So it's a fantastic tool for what I call grab and go science, okay? Because the idea is you've got all these tools, these sensors in one device, and you want to encourage the kids to use that device. So it's not like something you're going to keep in the closet and you're going to check out, once or twice a year to do experiments. You're going to keep it handy in the classroom. So if somebody has an idea, they can immediately start exploring that idea. So that's the whole concept behind databot. And it has lots and lots of capabilities for integration with other systems. That's what these ports here are for. You could literally integrate it with a robotic platform like Lego or maybe Sphero or Vex. You can add on your own sensors. You can have it control devices. It's also got Wi-Fi built into it, so you can put it on a network. And you can do things like IoT projects. So very high ceiling. We've got lots of people at the university level and high school level doing things like machine learning. But again, out of the box, so simple to use. I mean, it's designed really for somebody even at kindergarten level to be able to bring live sensor data into the classroom.
Robert, how did you come up with this concept?
My wife and I founded this company based on a lot of experiences we'd had, and a lot of them were overseas, deploying fairly complex STEM labs for, ministries of education and organizations that wanted to start doing STEM. And we designed these labs, which were beautiful labs. They had lots of equipment like 3D printers and robotic systems, electronic trainers, life science kits. But it was so overwhelming for educators that had no background in the pedagogy or the equipment of STEM. So literally we would go into these labs, set them up, and the teachers would be so overwhelmed by the amount of technical information that was required. It was very intimidating. So we put a lot of thought into it in terms of what would be the ideal tool that you could use to get people started. And that's how databot grew. We wanted something that was very small, friendly, unintimidating, something that people would enjoy working with, something that you could teach all the core sciences with, but also has that whole, STEAM ecosystem around it that you can incorporate coding and all these other things. So that's really the backstory of where it came from. We launched the company just before COVID, which I call us a twice startup now because we started up, everything shut down, and then we started up again. But in a lot of ways, it was good because version 1 of databot got out into, about 1,000 classrooms, and we had lots of teachers that we worked with during COVID. that gave us lots of feedback, and version 2, which you see now, is much better, and it's incorporated all kinds of great things that came directly from the classroom. So this slide is an overview of the 2 main softwares we use. There's a list over here of many other things that people are using. But again, out of the box, so simple. You just connect to it with this app called Vizi. You scan a QR code on the lesson plan, and it brings in these icons. You tap on the icon, and it loads a pre-configured experiment that's going to be displaying data. And it might be 1 sensor, or it could be 4 or 5, depending on the experiment. You're not limited. You literally can have all of the sensors displayed simultaneously if you wanted to. This other platform is called Microblocks. It's a free open source drag and drop environment by one of the original creators of Scratch. So it's very Scratch-like. So very portable. If your students are already doing Scratch, very easy for them to transfer over to Microblocks. And I'll show you some examples of it. You know, it's a remarkable platform because it's optimized for microcontrollers like databot. So it's really designed for physical computing. So we're going to look at a few examples of how Vizi works and give you some very specific examples of experiments and how people are using it in the classroom. This particular slide I wanted to share because it shows you that QR code concept I was mentioning earlier. So Vizi, you click on the little plus sign here on your main screen, and it comes up with an option to scan a QR code. You scan the QR code in off the lesson plan, and it's going to bring in, as I said, these pre-configured experiments. So it's that easy to use. There's not a lot of setup or configuration. We've actually timed it. There's actually a video on our website. You can literally set up Vizi, install it on your phone or a tablet, and scan a QR code and be gathering data in 60 seconds. So it's that easy, which really reduces the overhead for training and things like that. Some people put a lot of time into developing very sophisticated projects with it, but you don't have to do that. You can do just very simple things in the classroom almost immediately. So here's an example. So this one is a what we call a data mystery. And we do these data mysteries around different topics. The idea is you present kids with a set of data and you don't tell them what it is. Okay, you tell them, okay, we've got this temperature data and it's acting very strangely if you look at it. We've got 2 different temperature probes that are being read, and they're both going high and low very quickly, right? And if you look at the data more closely, you'll notice that they're opposites. One's high when the other's low. And it's also interesting because if you look at the data set, you'll notice that the high points are getting lower over time and the low points are getting higher. So you pose these data mysteries to kids and you say, okay, what could be actually causing temperature fluctuations like this? And you start delving into the data, okay, let's look at the temperature range. What might that, that could be an indicator if it's super high or super low. And then you start looking at the timing. Okay, how much time is there between those variations? And then, is this an artificial circumstance or is this something that could happen in nature? What in nature actually causes temperature changes? So these data mysteries are great fun. You break kids up into groups, you have them work through different questions, trying to figure out, okay, what could be causing these different anomalies? And then you do a final result, and they all give you your guess, and then you do the big reveal. And in this case, this is one that it's this little water bath experiment up here where you're swapping ice cold to warm water every 30 seconds, and you're getting this really beautiful graph of thermal transfer. So you can see that over time, if you continued doing that for as long as it took to get to equilibrium, it would finally match out and flatline. So you have the kids actually replicate the experiment so that they can see, okay, this is how that data set was created. So it's a fascinating, interactive experience with data where you start to think about data in different ways. You're trying to analyze it just in an abstract fashion, first of all, and then you bring this whole concrete experience in that shows you exactly how it works. So we have some really interesting data mysteries on our website that I would recommend you take a look at. They're a fun thing that you can do even if you don't have a data bot. You can pose questions like that and have mysteries that kids can help you solve. So I wanted to present a couple of different examples of lessons that are available. So the data mysteries are all on our blog. Sensor Starters is the series I mentioned that introduce all of the different sensors on board databot. Okay, so the idea, of course, with a sensor starter is to provide some background on how the technology works. Also introduce kids to where is that sensor used in the real world? What is it actually monitoring? You know, what's it reading and what are the units? And we also show you where it's located on the board. And then there's two fun activities in each sensor starter so that you actually use the sensor. The carbon dioxide one, for example, is breathing on it. And then also learning how to control it, you know, using, you know, what can you do physiologically to change the values of CO2. The one displayed here, down here in this lower right-hand corner, is a really fun one. The kids actually test how accurate the altimeter is, because the altimeter, of course, is based on air pressure. And they learn that just running up and down a set of stairs, they can see changes in air pressure, you know, these invisible forces again. Air pressure is all around us, and we can see how it changes as we go up and down even a simple set of stairs. And then they correlate that to the altitude and see how accurate it is. So
And
sensor
also it
start,
shows how sensitive is a databot.
exactly. Yep. Yeah, and usually it's you know, air temperature is fluctuating all the time. So I don't recommend using that altimeter for hang gliding, right? Because it's always going to be changing a little bit. But it's very accurate in terms of the kinds of things that you're introducing kids to. It's literally within 3 to 5 inches when you measure it and you have kids do this accuracy test. So here's another source of lesson plans. And this one's fantastic for people to use for planning your curriculum, you know, over the course of a quarter or a semester. Let's say that you know you're going to be doing characteristics of light, for example, during a week. You can use our ChatGPT engine, and it's been trained with all of the sensors and capabilities of databot. And you can ask it for specific suggestions for the lessons that you're going to be doing. So let's say that you wanted an activity around characteristics of light, reflection. You can put that in and tell it, okay, I need something in the 5th grade that's going to do this. And it will actually generate a lesson plan for you and provide you all of the standards, a phenomenon to kick off the activity, give you the instructions for the experiments to conduct. So it's a fantastic tool for brainstorming and figuring out how to use databot in a customized fashion with your curriculum. So for those of you who are using AI in the classroom or have been using GPT for research, this is a fantastic application. Once you understand how to use it for generating lesson plans and ideas, you know, for bringing your classroom, you know, to life, it's a fantastic tool. So here are a few examples. We're going to go through a few examples of science, and then I'm going to show you the coding side, just a couple examples of that so that you can see the other side of it. So I've got an example here of elementary math and science. So this is a great teacher. He actually does testing for Smithsonian. So they provide him curriculum units and he does testing, provides feedback. This is one of the Smithsonian units that you see the pictures of here on the right. Now, on the left is actually his description. I asked him, you know, just to send a brief summary of his databot experience when he got it. And he sent me this. And this one, of course, is a great example of using it for environmental studies, because the first thing they did is they went out and they started gathering weather and climate data. So, you know, he gathered measurements in temperature, air pressure, and humidity. And then they correlated that to trends and patterns in their region. And so it was a great experience for kids to actually go out. Again, you're reading and having that real-time data experience. And it takes that abstract concept of climate and weather patterns to a much different, you know, realm, because you're physically going out and measuring those things very easily. So that's a great example of elementary. Got an example of middle school here next. This is another data mystery. This is actually my favorite. You present kids with a data set of, you know, there's this very strange thing going on with this air pressure situation. And you can see on the left-hand side, you present it and say, okay, first of all, there's this giant spike in air pressure, okay, from the baseline. And then it drops down about halfway. And then it kind of stair steps up a little bit at a time. And you can see that it does it, you know, over about a minute and a half. You know, you're looking at the time frame. So what could be going on? And this is a great one because, you know, the last time I did this with some kids, there were some really great ideas that came out of it from the kids. And they were very scientific about it. They said, okay, what could be impacting air pressure like this, and they came up with the idea, okay, it might be temperature, it might be volume, one of those things might be happening. Anyway, at the end, we do the big reveal again, of course, and you explain, well, this is a really cool one because databot is literally inside a balloon and you're inflating it. So that's that big pressure surge right there where you do the initial, break of the balloon, and then it starts to inflate. And then these are the different puffs. And then, of course, there's the big explosion. We make them blow it up until it actually explodes, and then it drops back down. So great example again of really fun experiences with data.
And also, Robert, it is a great example how students are engaged, because a lot of experiments are designed for involving them as kind of co-authors.
Yep, exactly. No, and it, your supporting tools slide at the beginning of this, what we do is exactly what you were identifying, it's the active learning, it's instant feedback, there's just no alternative to learning like that.
And
Kids really,
fun.
yes.
You definitely have fun even talking about it.
So here's a high school example. So this teacher had her kids do a campus-wide air survey, right? So they went out and took CO2 levels at different times of the day all over the campus. They aggregated that data and used a tool called Data Classroom, which is a software tool for calculating and getting kids used to visualizing data. And it was a great experience, again, because they could see different times of day. Rooms were at different levels. A good example of that is just a classroom. If you're monitoring your air quality levels in the classroom of, let's say, humidity, carbon dioxide, and volatile organic compounds, you'll see surges as kids come in and out of the classroom, right? You got 30 warm bodies coming in, you're going to see changes in temperature and humidity and carbon dioxide almost immediately. So again, these kinds of applications, again, bringing abstract concepts to life. Air quality is one of the, I think probably one of the top experiments that I hear about with teachers. They do a lot of environmental explorations with air quality in the school parking lot and things like that. So this is a summary of just science, okay? And then we're going to take a look at the microblocks material fairly quickly and then wrap up with a question and answer period. But benefits, these directly align with the NGSS engineering practices, science and engineering practices, because anytime you're doing work with databot, you are collecting data, you're analyzing data, you're interacting with data, visualizing it, explaining it, presenting it. So there are a lot of just basic practices that you're reinforcing every time you do these activities. And then beyond that, of course, you're becoming familiar with just using instrumentation and scientific equipment. You're learning experimental procedures. So a lot of benefits in terms of just natural, comfortable science education, making kids comfortable with equipment and scientific concepts. And again, I mentioned that, it's very cross-disciplinary. You can teach literally all of the different topic areas with databot. So let's take a quick look at microblocks and how it works. We have this whole series of curriculum called Coding Starters that, again, just like Visi, make it super easy for you to get involved with coding. Now, microblocks is very portable. You can run it on a Chromebook. You can run it on any browser, based computer, whether it's a Mac or a Windows system, just needs to have an Edge or a Chrome browser. So it's designed to be very portable. But you can see in our coding starters, they're very simple. They're typically 2 or 3 pages, and we introduce things like this little piece of code. This is a very simple loop. So it says, okay, do this forever. Say databot light level. When you run it, it outputs a little bubble, and it'll give you the light intensity. So you can actually put your hand up and down over databot, and it'll immediately change. So again, you're having that immediate response with data because you're communicating with databot in real time in this coding environment. That's one of the things that differentiates microblocks from all the other platforms out there, is you're literally interacting with the device in real time. So as you change code, you're going to see immediate responses and values. And this one, the second piece of code, is add a graph. So it's got graphing functions built in. So again, that immediate response, you get kids actually playing with data in ways that are, really novel. It's a perfect tool for coding for science. The graphing within microblocks, you can actually graph up to 6 simultaneous values. So you can do some really interesting and complex experiments. This is a slide that I put together just to show the high end, of course. Now, this was all coded in microblocks. You're using databot as a greenhouse controller. And the tour that I gave you earlier highlighted a lot of these different ports, right? So here, for example, we've got the 2 temperature probes. One of them's reading air temperature. One of them's reading soil temperature. And this whole project is a smart greenhouse. So you're using it to monitor the soil temperature and the conditions in your greenhouse. You're monitoring these environmental conditions, light, air pressure, humidity, CO2. And so, for example, when you note that the soil's getting a little bit dry, databot can automatically turn on this little relay and operate a pump and water it. So this is a good example of, some advanced applications. Here we're representing IoT. You can beam all of this data also into the cloud, so kids could literally check on the status of their greenhouse from home at any time. So that's a good example of the high end of microblocks. So you literally can start out very simply, just reading, simple temperature probe readings, or you can do very high end control type activities.
And it is also a representation how databot is what role databot is playing in building a system, a systemic education, because this is what you are actually designing.
Exactly. And, the thing you mentioned at the beginning, databot in every classroom, I truly believe that because it's such a versatile tool. A workshop we did last week, one of the teachers presented on using it in the kindergarten class. And she said, can you imagine how fluent kids would be in data and science if they started at kindergarten with this tool? And it was available at every grade level. Every grade level you would get more sophisticated, but you'd be so comfortable with the data that you're collecting and the things that you're doing with it that you would start doing real science very quickly, because that's really the goal. Get kids comfortable and have them start to conduct their own experiments.
And also, it is not only consumption of technology like with with the phones, but this is just technology as a tool for them to be developed and to develop their skills.
Exactly. And this, jump past that one. This is just some other examples of how it's used to give you an idea of the breadth, integrating it with drones, flying missions where you can gather air quality data. These are great quality missions for kids to work together as well. So we always team up mission style activities, in pairs. So for example, here we've got one student that's acting as the pilot and the other is acting as the data scientist. And together they're working to solve problems. This is another great example of the type of interactive activities we do, right? So you've got a whole summer camp series that are they're very engaging because you're putting the kids right in the middle of that data experience, whether it's learning acceleration. This is one where they're leaping around and trying to accomplish the highest levels of acceleration. This one is air pressure. That's our balloon experiment there. This one, they're using databot as an inclinometer and learning about acute angles, obtuse angles. They culminate with doing an activity called the limbo, where they're trying to get the most severe angle in their back bend to go underneath the limbo pole. So all these things are, really fun, interactive experiences with data. Whole Lego integration. So a lot of people are using it within Lego robotics. This is a great environmental activity here as well. So this one is all about carbon sequestration. You can use databot and its inclinometer to actually measure the height of a tree, and you can use different calculations to calculate, okay, how much carbon is actually stored in that tree. So it's a great introduction to technology, tools, and also, of course, the carbon cycle. Anyway, lots and lots of ways to use it. We have a lot of professional development seminars going on this summer where people are teaching, all kinds of things, because some of them are focused at the high school level, some of them are focused at general STEM. Some of them are focused at coding. So lots of ways that you can use databot. And then here's how databot is configured. We're about out of time, so I want to make sure I leave enough time for some questions. But again, very, very simple. We've made the kit very simple. We don't want people to have to chase a lot of inventory or lose parts. So it comes with a charging and coding cable, a lanyard that loops through one of the corners so you can wear it around your neck or use it as a pendulum. And it comes also with one of the temperature probes. So very simple, but very powerful in terms of the things you can do with it.
And the important feature is that this is rechargeable.
Yes, yep, it's got a rechargeable battery built in, so it takes about an hour to charge, and it'll run 4 to 6 hours, depending on what you're doing with it. So it works out about perfectly for a class day, because you'll charge them in the morning, and then you might use them, you know, for 20 minutes or so during a class period, multiple times throughout the day. So do we have any questions?
Don't see it yet. Let's continue. Because we definitely have a lot of information to share.
Yeah, we can take a look at some other examples. So this next screen actually is a bundle that identifies a lot of the curriculum titles, right? So because you can do so many things with databot, we've put together some bundles. This is a very popular one for STEM hubs and media coordinators, because they will get several of these classroom sets, and then teachers can check them out. And depending on, you know, the teacher, they might be doing an after school program, or they might be doing Lego robotics, or they might be doing coding. You know, all of that curriculum is included with this bundle. So it's, you know, it's been a very popular item for resource centers where they're checking things out. So this was the next slide.
Before Robert, can you go to the slide so that databot is in between of scientific probes and low probes? Is it possible for you to find that? Because
You know,
I really like this place which databot is so kind of occupying, because it's so unique.
Yeah, I took that slide out, but I can explain it. So basically we have this ecosystem of sensors out there in the world, right? And they go from a very low price point to a very high price point. And within that ecosystem, you've got things like Arduino sensors, you know, microbit has sensors built into it, things that you can have access to for $20 or $30. Now, on that end of the spectrum, it's very inexpensive, but it is really designed for physical computing and maker spaces, because you're going to be building, coding, and designing something. And if you're a 4th grade teacher that just wants to teach, you know, air pressure or weather, you don't want to have to fiddle with coding, breadboards, alligator clips. That's really not the intent for, you know, what you're trying to do that particular time. So again, databot plays in that whole ecosystem, because you can code it and do all those things with it, but it's also a super easy to use science tool. So it kind of sits in the middle of this price range of sensors and capabilities. On the low end, you've got the things like Arduino and microbit. On the high end, you've got all of your classic probeware from Vernier or Pasco or Data Harvest. You know, this is beautiful equipment that allows you to do some really great classical, you know, lab experiments in the classroom. But it's also very expensive. They're individual sensors, so they're not combined into one device. They have a higher learning curve. You have to be trained on how to use them. And they're not something tough and rugged like databot. You're not probably going to want to put some of those sensors, which some of them are several $100s, you know, onto an air rocket and launch it. So, you know, that's kind of, you know, another differentiator for databot. And databot can do all of those classical science experiments because it's got all of these sensors built in, but it's much less expensive. You know, the price point for databot is $189 for 16 sensors. So extraordinary the amount of things you can do with that single device.
And the quality of sensors is high scientific. you can actually participate in so people's science and real life experiments using so databot.
Yeah, it's highly highly accurate. All of the data sheets for the sensors are actually available online, so you can take a look at the resolution. And these are all industrial sensors. These are used in the real world. So the applications that you see in our sensor starters, where we're talking about, real world applications, those are the same sensors that are used in the real world. A good example is the accelerometer. A simple thing that everybody does, of course, is with your cell phone. If you tip from portrait to landscape, it knows and it'll shift orientation. Well, it does that because it's got an accelerometer built into it. And that same accelerometer is built into databot. So great example right there of how these sensors are used in the real world.
And we have a question. So what device is most commonly used with databot? Because you said it's but just a server, so it's using any kind of devices, no limitations. It's not designed for ICEP, a cell phone, or something. But the question is about do you have so what device is commonly used, most commonly used, and do you have any kind of restrictions or data, which is better, which is lower for so worth device to use?
Back here to the slide about Visi. So Visi is the most commonly used application. In fact, I would say, 80% of our, especially our elementary educators, never go beyond Visi because you can do so much with it. So it is a smart app. So it runs on iOS. So it'll run on your iPads or iPhones. It'll run on Android. So it also runs on Chromebooks as an Android app. So you've basically got iOS, Android, and Chromebook that you can run this app on. And that, as I said, that's by far the most popular platform. You've got all these other things you can do with it, but for the most part, people use that. Now, the other piece of that, it's very easy to export the data. And I think this, actually, next slide shows that. This little picture right here actually shows you the export process. So let's say you wanted to collect data using Visi, and then you wanted to have the kids take it into a spreadsheet like Google Sheets. That I see a lot as well. It's very simple. It's a 3-step process. You tap on the export, select the format, and then select how you want to transfer the data. You can drop it on a drive. You can email it to yourself. You can literally text it to somebody. So very simple to get the data out of Visi as well.
So, and do you have bugs in so in using it?
Sorry, say again?
Bugs. Do you have bugs?
Oh, do we have bugs and errors?
Yeah.
No, this
And
is,
what do you do with them?
yeah, no, this is pretty solid. Now, of course, you're going to get anomalies in data collection, which is one of the things you want to teach kids. So as you gather sensor data, you might be doing an acceleration experiment and you'll see a wild spike, for some reason. And those things, it might be, it could be anything, it could be a little surge in electricity or something. But those kinds of things are great learning experiences because you need to teach the kids that, data is not perfect. Science is not perfect, your test results and the experiments you run are not going to match theory perfectly, and you've got to figure out why. So definitely anomalies and things like that are embedded into it.
Yes, and you see it's definitely unleashed creativity in the students and unleashed creativity in teachers when you use the databot.
I'll jump back to our last slide here,
Uh-huh.
so I'll let you conclude.
So what I'm trying to say that Eduforum, as you see, is not only vetting products, but we are seeking for this kind of product. And it's great presentation, Roberts. Thank you so much. And I already have thank you from the audience as well, that it is a great presentation, very useful, very important. And so this is what what Eduforum is doing. We are seeking for this kind of products, and we are also looking for different dimensions, how to use this product, how to move these products from makerspace to every classroom, not only specialty programs, how to use products in ecological education and environmental literacy, how our tech tools are supporting communication and languages, or how these products are used for students with any ability, and make them able to be so the student who is expressing their abilities from the point of abilities rather than from the point of disabilities. This is the tool which is enabling students' abilities. So, this is what Eduforum is doing. And now we have not a question, but a comment. It is striking how quickly students can get to discussion and analysis. They don't need to spend much time learning to use databot. They can spend most of the time thinking about the data. They can also get better at designing experiments. So this is what we have, so the comment from our audience. So thank you, Paul.
Yeah, one thing I'll point out on that too is in the app Visi, you can literally tap on a graph and it'll open up and kids can pan through the data set. They can zoom in on data. They can tap on data points. And I've watched kids figure that out within minutes. And so when they're competing, for example, for the highest CO2 level, they'll be zooming in on data and tapping on data points. And it becomes, again, a very natural excursion into a data set.
It's actually probably fearful for educators to give such a power for students to learn. But this is what we are trying to do. We are trying to upgrade ourselves as educators to the new learning environment. And the databot is a tool which helps us to do so. And our time is almost done. Let me just wrap it to remind you that Eduforum is your friend and is ready to help you with specific needs of you as educators and your students. So we are getting products. We are expanding these tools into new areas, and we are running free consultations. So whatever you want to do, just let us know, call us, contact us, and we are here to help. So thank you very much. And thank you, Robert, again. Great presentation.
Thank you for having me. Bye-bye.